Hi everyone, I'm going to be going over question 69 from the chapter 7 problems. This problem has to do with this block that is connected to a spring into a wall and is being pushed from equilibrium with a force of 20 newtons in the plus x direction. And then we're given a bunch of different information based on that. But part A wants to know, it says, what is the speed of the block when the back of the block reaches point B, which is right here, which is 0.25 meters right of point A. So this section right here. So the way we do that is through our conservation of energy equation. So we know that Ka plus UA equals KB plus UB. We need to factor in work though as well on the A side. So something that we can look at though is that at point A, this was at equilibrium, so it didn't have any kinetic energy and it didn't have any potential energy. It was just sitting there. It was just, everything was balanced. So this right here equals 0, and so we can really just kind of forget about it. So that means that W equals KB plus UB. And since we're looking for kinetic energy, right, we're looking for the velocity, let's get KB by itself. So we'll get KB equals, I'll just write it up here. So KB equals work minus potential at B. Let's see, work minus UB. So here we have our equation, and now what we can do is we can expand this. So mv squared f delta x minus 1 half k delta squared. So we have this, and what we can do is we can solve for this velocity here. So what we end up with is v at point B equals the square root, and we're going to end up with 2 times f. And I'll just put, as I do this, I'll put in the actual values at this time too. So 20 times delta x, which is 0.25, minus 1 half. The k was given to us as 40 Newton meters times 0.25 squared. And then at the bottom of this, we're going to end up with the mass. Oh, and the mass is equal to 0.5 kilograms. So when we plug that into our calculator, we end up getting that the velocity at point B is equal to 3.87 meters per second. So that's our velocity for B. Now, part B wants to know, it says when the back of the block reaches point B, you let go of the block, how close does the block get to the wall on the left side? So it stretches to here with that force being applied, it's let go, and how close does it get over here? So we'll call the point over here point C. And so what we'll get is we'll get KC plus UC equals KB plus UB. Now KC, as far over as this can be, all that kinetic energy is going to be depleted. So this is going to equal 0. So we'll just get rid of that. And so we're equal with the potential energy at C equals the kinetic energy at B plus the potential energy at B. And so now what we do is we can expand some of this. So we'll get 1/2 K times delta X squared. And I'll put a subscript 2 because this delta X is different than what we've used before in part A. It's actually a delta X within this region. So we'll say delta X squared equals, and then KB is going to be 1/2 MVB squared plus 1/2 K delta X squared. Now this delta X is at point B, so it's the original delta X here. But now what we can do is we can solve. We know a lot of these things, but we're looking for this delta X right here. So let's solve out this side first, just to make it a little easier. So we'll end up getting 1/2 mass 0.5. VB we know is 3.87 squared plus 1/2 times 40 times 0.25 squared. And that is going to equal this side right here. So equals, I'll just draw an arrow. So we'll do that in our calculator. And what we end up getting is that this side is equal to 4.994. So 1/2 K delta X squared equals 4.994. And now we'll just keep solving for delta X. So we'll end up getting, so I'll multiply this by 2, and then dividing that by K, which we know is 40, and then taking the square root of that, we end up with delta X. So like I said, I multiplied by 2, divide by K, so we'll get 2 K square root. And that is what equals delta X. So plug that into the calculator and we get 0.499. So we'll just say 0.5. So delta X equals 0.5. But we still need to subtract it from this value to get how close it is to the wall. So 0.6 minus 0.5 equals 0.1 meters. So that is how close this block gets to the edge, that left edge of the wall, after it's let go at point B. So hope you learned something, and I'll see you in the next video.